Hello, this is Dr. Vani and welcome to my classroom. Today we'll be looking at MCQs from momentum and collision as part of the review. So let's look at 6. A 5,000 kilogram freight car moving at 4 kilometers per hour collides and couples with an 8,000 kilogram freight car which is initially at rest. The approximate common final velocity of the two cars is. What type of collision is this? It's a perfectly inelastic collision, right? Because they're moving with the same final velocities. So 5,000 times 4 kilometers per hour. So it's going to be 5,000 times 4 plus the initial velocity of the 8,000 kilogram freight car is going to be 0 because it is initially at rest, right? Would be equal to 5,000 plus 8,000 times V. So this is simply going to be 20,000 divided by 13,000. Right? And that's equal to, you said it was 1.5 kilometers per hour. So that's a simple, perfectly inelastic collision problem where you're going to have the same final velocity for both the objects as they're moving together as one combined mass. All right, number 7. The rubber ball is held motionless a height h0 above a hard floor and released. Assuming that the collision with the floor is elastic, which one of the following graphs best shows the relationship between the total energy E of the ball and its height h above the surface? Which one of these graphs actually represent the total energy E and its height h above the surface? Which one do you think would be the answer to 7? Elastic, right? What is the main characteristic of elastic collision apart from the fact that momentum is conserved? Energy is conserved as well, right? Because it is an elastic collision, energy is conserved as well. So the total energy is going to remain constant. So the answer is A. Keep in mind that when it is not an elastic collision, that means if it is an inelastic collision or a perfectly inelastic collision, some amount of energy is going to be lost as heat. Okay, so the total mechanical energy is not going to remain constant, Kirti. But the main thing you need to focus on is the fact that this is an elastic collision and therefore the total energy remains constant. You get what I'm saying? And so, so that is the key thing. That is the main reason why A is the answer. Apart from the fact that, you only remember that the total energy is always going to be constant. Not necessary. When there is friction and the friction is significant, then keep in mind that law of conservation of mechanical energy does not hold good. The initial mechanical energy is not equal to the final mechanical energy. It is equal to the final mechanical energy plus some amount of energy that is lost as heat, right? So that is something that you always have to keep in mind, that because it is elastic collision, the total mechanical energy remains constant. So answer to 7 is A. Read the question carefully, guys. It's very, very important. Okay. 8. 2 cards are held together. Card 1 is more massive than card 2. As they're forced apart by a compressed spring between them, which of the following will have the same magnitude for both cars? Is it going to be the change in velocity? Is it going to be the force? Is it going to be the speed? Or is it going to be the velocity of the objects? Which one is going to be the same in magnitude? Forces are going to be the same. The force is going to be the same on both the cards. What is going to be different is going to be the acceleration of the cards, right? The acceleration of the cards depends upon the mass, but the force, the magnitude of the force is going to be the same on both the cards. So answer to 8 is B. 9. A ball with mass of 0.50 kilograms and a mass of 6 meters per second collides perpendicularly with a wall and bounces off with a speed of 4 meters per second in the opposite direction. What is the magnitude of the impulse acting on the ball? They're asking you to find the impulse acting on the ball. How do we find that? What is impulse? Keep in mind that F times T, right? F times delta T. This is impulse, and this is equal to M times VF minus V naught. So whenever they say find impulse, you can find it in two ways. You can do force times delta T, or you can do M times VF minus V naught, because impulse is the same as change in momentum. F times delta T equals M times VF minus V naught. So it is going to be 0.5 times VF minus V naught. So that is going to be, now be careful guys. It says it moves with a speed of 6 meters per second, collides perpendicularly with a wall and bounces off with a velocity of 4 meters per second in the opposite direction, right? So if you are taking 6 meters per second as positive, then 4 meters per second is going to be negative because it's bouncing off in the opposite direction. So this is going to be negative 4 minus 6. So you're going to end up having negative 10, and negative 10 times 0.5 is going to be negative 5 newtons times seconds. But here we are looking for only magnitude, and since we are looking for magnitude, we don't have to worry about the negative sign, because that is simply saying that the impulse is acting in the opposite direction. So your answer is going to be B. Again, be cautious with the fact that here the ball is bouncing off the wall in the opposite direction. So do not forget to put the negative sign. And sadly, on questions of this sort, you will have both the answers. You know, you will, if you do 4 minus 6, which is going to be negative 2, and negative 2 times 0.5, which is going to be 1, is also one of the answers. So it's very easy for you to get this, you know, wrong. So be careful with the direction. All right, 10. A cart with mass 2 meters has a velocity v before it strikes another car of mass 3m at rest. The two carts couple and move off together with a velocity of, let's see. Again, you are using conservation of momentum here. The cart of mass 2m is moving with a velocity of v, and it bounces off with another cart at rest. So the initial momentum of the second cart is going to be equal to 0. Then the total mass, the combined mass, is going to be 2m plus 3m, which is going to be 5m times the velocity vf. And so vf is going to be equal to 2mv divided by 5m. You can get rid of m, and this leaves you with 2 over 5v. So the answer to 10 is B.